All right. Good morning, wonderful people. Let's get started. So, by the end of this section, you will be able to solve quadratic equations using completing the square method. So this is a new method. So we've already covered some of the other ones like factoring, okay? Let's go ahead and solve quadratic, because we've already done some of these with perfect square trinomials, where basically you're just solving and moving everything to one side. And I know we've done this in a couple of previous lessons. So, well, maybe if we just get started, it'll be a little bit easier. So first off, we don't set it equal to 0. So it's not set to 0. Sometimes you will have numbers on the outside. When you have a number on the outside, then we can still try to factor it. So I'm going to go ahead and factor this like that. And we use our backwards FOIL method. And we need two numbers that multiply to positive 49. So 7 times 7 is probably one number combination we can get to multiply to get to 49. And it has to multiply to positive 49, which means that there is also a chance that they could both be negative. And how you tell that sign is to look at this one here. So when you see this and it's positive, that means these signs are going to be positive, because remember, the middle terms, the OI part, need to add up to 14. So 7 plus 7 is going to add up to 14. A quick rundown on some of the factoring. All right, and here, since I have a perfect square trinomial, we can also I'm going to put them together and as a group and say that the group is squared, because remember, that's what this means. It means that there is a group and there's two of them, two of those groups. And then from here, I'm going to have to take the square root of both sides, because I want to get rid of this square. Okay, and remember, these are inverse operations, which means that they are opposites of each other. So they will undo each other, and that's exactly what's going on. They will undo. So no more radical. And I can take the square root of 4, which is 2. Let me go ahead and make that 2 a little bit better. And there we go. But remember, when you take the square root of something like this, you also need to consider the positive and the negative possibility, because there are two possibilities. Because remember, you can also, like if I wanted to multiply to get 4, like I could say negative 2 times negative 2, and that would still be positive 4. All right, now here's where things go a little bit different from how we did it before. I want to break it into two separate equations. Let's see, how can I put it right here? So we take this and use the positive outcome, the positive possibility. And over here, we're going to go ahead and write it in a second equation, but we're going to consider the negative possibility. Oh, excuse me. See, so one positive, other negative. And then I'm going to go ahead and continue solving it, because we got to get this x all the way by itself. So I'm going to minus 7 from both sides here, and I get x equals negative 5. And for this side here, it looks like I'm going to have to do the same thing. But they're both negative, so negative 2 and negative 7. Put those together, you will get negative 9. And just to keep things consistent, I'm going to write my answer, my solution, in set notation. And don't forget, when you do find the solutions for these kind of problems, it will be a parabola, and the parabola will cross at those points. Maybe I'll show you really quick on one of these. So I'm going to go ahead and go over to my graphing tool. So x squared, right? We've got our parabola, 14x plus 49 and equals 4. Let's see if it'll work out. So in this case here, it doesn't know exactly where the parabola is going to go. So, you know, it doesn't know enough to make it open up or open downward. So it just sort of makes these lines here. But if I were to minus, say, 4 from both sides, I'm going to minus 4 from both sides. So minus 4 here, and I'm going to get rid of this 4 and set it to 0. Actually, I probably don't need that. There we go. Now it's going to be a parabola, and it's going to cross here and here at -9 and -5. So you can also use a parabola to check your work, okay, to see if it's gonna cross there. But really, I'm just trying to show you that that is what the solution is. That is what you're looking for, you know, at the end of the day. All right, let's continue back here. So I'm going to do the same thing, and in this case, it says it's going to be a perfect square trinomial. So I'm going to go ahead and just think of two numbers that can multiply to 9, which is going to be 3. We know this is going to be a square. It's going to be a repeat like this. So you can write it like this if you want. In fact, you know what? Maybe I will. Maybe I'm just going to not skip any steps. And we need them to multiply to +9. But they need to add to -6. The only way we can really do that is if they are both negative. So again, -3, -3. They add up to, or combine to -6, and -3 times -3 is also going to make 9. And get our first number going. So our first number was x, so x times x is how we get x squared. And there we go. We have a matching set of groups. So to get that matching set of groups, we're going to go x minus 3 square, like that. So again, I put the group together and I just put a square there to show that there are 2 of those in the group. And I'm going to go ahead and undo this group because I want to get rid of that 2 power. So to get rid of the 2 power, again, we're going to do the inverse operation, and that should get rid of it. So x minus 3 equals positive and negative. Oops. Well, for this root 20, we're going to have to kind of break it down into a little bit more of, we got to do a little bit more for it. So root 20, break that down into root 4 and root 5. We can take the square root of 4, but we cannot take the square root of 5. So 5 is going to have to stay in the radical, just like that. All right, now we got to break it down into 2 equations like this. But in this case here, we can't really add anything to it, right? Because if you think about it, it's kind of like 2a or 2n. It's like a variable. If I were to add 3 to both sides, plus 3 here and plus 3 here, because I'm trying to get that x by itself, x equals, I cannot put these together, okay? I cannot get like 5, root 5 or anything like that. Oops. So since they are not like terms, I'm going to have to put them together. Something like this. And if we use our calculator, we will not get a whole number explanation, a whole number calculation. So let's go with square root of 5. So let's see, square root of 5. Right, we get a number like this. an irrational number, no repeats, no pattern that we can follow, times it by 2, and then add 3, you know, we would get something like this, but we'd also have to do another one where we would subtract it from 3. But the point being is that kind of answer is not really good. It's not a very good answer. So I'm just going to leave it. We're just going to leave it in this form here. So this is our solution here. And for this one here, so the solution is this part here. So these are the two kinds of solutions that we may end up getting. All right, so let's go ahead and move into what we're doing today. And that is completing the square. So in the examples that we just did, we had them already basically set to go as perfect square trinomials. But in this case here, we got to make it into a perfect square trinomial and pretty much do the same thing. And that's what they call completing the square. So what we do is we rewrite it so that A and B are on the same side and C is on its own. And this one might sound familiar because, well, okay, so we don't need any number in the front. So if you have a number in the front of your equation, we got to get rid of it, all right? So there cannot be anything in the front. Once there's nothing in the front of the equation, we're going to go take the b value. So if you remember, there's that little tune where I was kind of like singing it, and I said, take it, half it, square it, and then add it to both sides of the equation. So again, this is something that we've done in a previous lesson, but I think we're just going to go a little bit more further. So once we have that b and we take it, half it, square it, we should be able to create a perfect square trinomial, which we will then factor it. And then take the square root of both sides, and this will have two cases because there's a positive and negative result that you can get from it. So again, this is basically what we did on the last example. Solve both equations and simplify all irrational and complex answers. So if anything has a root in it, you're basically just going to do what we did with the very last one and leave the root in there, but make sure that it's in simplest form. And it looks like when it says complex, that means imaginary. So imaginary, again, it's imaginary thingies are like the I letter. So got that cursive I. And basically what that means is there is a solution. So it's not no solution, but it's what we would call imaginary solution because it's not actually crossing the x-axis on the graph. It's just kind of like wanting to cross. It's thinking about it, basically. Okay. I hope that's a good enough explanation. Maybe it'll make a little bit more sense once we actually get to working on some of these. So let's go ahead and work on some of these. So solve the quadratic equation by completing the square. Okay, so first thing we got to do is put it in the right format, right? So we gotta have our 2x numbers basically by themselves. Get the 2x numbers so that they're all by themselves. I'm going to leave a space here. Well, let's see. Do I need to do this just yet? How am I going to write this? Let's just, oh, well, I'll just keep going. All right, now we have our b value. So we're going to have to take it, half it, square it. So take it. And okay, so we take it, then we half it, then we square it. So -9 times -9 is going to be positive 81. So I'm going to have to put in positive 81 here. Now, if you remember on the last one, when we did this Before, we did it to the same side, but in this case here, I'm going to go ahead and put it on this side because that's what equation means. Remember, equations have to stay balanced. So, and if you do something to one side, you got to do it to the other side. All right, now this should be a perfect square trinomial on this side of the graph, on our left side, the first side as I call it. So to factor it, I need two numbers that multiply to 81. Okay, and that should be pretty easy. And a hint too is that it's usually going to be the middle step of your take it, half it, square it. Or again, you can just stick with your regular rules because 9 times 9 is 81, but we need it to we need it to add to negative 18. So that's going to be negative 9, like that. And here I got to add, well, negative 56 and 81, which is going to be 25. And just to save a little bit of space here, because I feel like I'm going to run out of space on this one here, I'm going to take the root, because we already know this is going to be square, and it's going to cancel one of them out. But I also need to take the square of this side. So x minus 9 equals, and we can take the square root of 25. So plus and minus 5. Okay. We break it into two equations, x minus 9 equals positive 5. And the second case where what would happen if it was negative, so negative 5. So again, we just split it right here where one is positive and the other is negative. Add 9 to both sides, so plus 9 here and plus 9 there. And since I'm doing the exact same thing, if I'm doing the exact same thing, I usually just do it all at once. So I'm really at the last step here, so we go ahead and put our group symbol, and I'm going to add 9. So let's see what we got here. We have, it looks like this one's going to be our lower number, so I'm going to do this one first. 9 minus 5 is 4. And we're gonna do this one here. So in this case here, we got 5 plus 9, and that would be 14. So our solutions are 4 and 14. Those are the two solutions that we got. Okay, so I know it's a lot of stuff going on, so let's go ahead and keep it moving. All right, so remember on the directions, it says that this A value cannot be there, basically, right? So if there is an A value, we have to divide everything by the A value so that there is no A value, so it just becomes x squared. So let's go ahead and get rid of this. And I'm going to divide everything by 2. So cancel that out, and we get x squared minus 16x equals, I'm going to leave a space here because we're going to get negative 15. And I'm going to need to put something in there. All right, so we got to make this into a perfect square trinomial, and the only way we can do that is if we have this number, so our b value, so we're going to take it, half it, and wait, no, we take it, half it. Oh, you know what? Yeah, I almost almost forgot to half this number here. So it should be 8. I kind of thought that would be a bit of a big number here. So, all right, so we take it. So negative 8 is our real b value. Take it, half it, and square it. So that would be 16. So I got to drop a 16 right here. But I also got to keep it balanced and put another 16 right over here. There we go. Now this should be a perfect square trinomial. And I'm kind of worried that I'm going to run out of space here, like I did on this one here. I barely fit it in there. So I'm going to go ahead and we already know it's basically going to be a double bubble. Two numbers that multiply to 16. All right. But they also have to add to -8. So -4 and -4, combine those, you get -8. And x. But in this case here, again, just to save some space, I'm going to go ahead and erase one side, and I'm going to put square right here. Equals, and let's go ahead and put these together. So we have 16 minus 15, which should be 1. All right, now we gotta keep going. Take the root of both sides. So root here and root here. So by taking the square root of the root, the square root of the square, that will undo the radical. So we have no more radical. And we can take the square root of 1. Don't forget 1 is a square number because the square root of 1 is 1. Okay. Now from here, we got to break it into two separate equations because we don't have any radical expressions at all, which means we can get whole number or but we can get solutions that are rational, not irrational, like I'm not sure what we could at least have. Anyway, we also have to consider the negative possibility here. Okay, and I'm gonna continue solving. So I'm gonna add 4 to both sides. And since this is the exact same step, I'm just gonna add 4 over here at the same time, just to keep things moving a little bit easier. X equals, and let's see what we have. This cancels out. And we have 5, it looks like 5, and over here we will have 3. Okay, maybe I should start putting the -1 first. You don't really need to put them in order. If you said 5 and 3, I would still accept that as the answer. But in this case, I like to put my answers in numerical order. So I'm going to put 3 and 5. So solutions to this are 3 and 5. All right, so it looks like we are pretty much done with this one here. And again, this is not a particularly long lesson. I don't think so anyway. So keep moving. And now with this one here, you notice that we have an A value. Our A value is 4. And when you have an A value, sorry. Oh, come on. We got to get rid of this A value of 4. So that means I'm going to have to divide everything by 4. Okay, let me go ahead and divide everything by 4 because we cannot have that A value. I think this is one of those other things that's kind of new. Everything else, we kind of covered it in one way or another, but this is something that's kind of new. And again, I'm going to leave a space there. But this, I'm going to have to leave it as a fraction. All right, now we gotta find out what our v value was gonna be in order to make this work out into a perfect square trinomial. Just to save some space, I'm gonna put it up here. So take it, half it, let's see, take it, half it, square it, which it looks like we're gonna get -1. And square it, we get +1. So take it, half it, square it. And seems kind of weird, but maybe it'll work out. So I'm going to add 1 to both sides because we got to keep it balanced. So let's go ahead and turn this into a something like this, right? And just to save some space, I'm going to go ahead and do last number, so 1 times 1. And I'm going to erase one of these here just to save some space for myself. But they need to add up to -2. So -1 and -1, put those together, you will get -2. And there we go, it works out. You can check it too. So don't forget to check these. You know, if you're not sure, if you think something didn't work out the way you intended, check it. You know, it takes like, okay, so let's multiply this, multiply that, -1x, -1x. Yeah, together they will make -2x, and -1 times -1 is +1. So everything works out. I'm going to go ahead and, again, just sort of move along, skip this step here. And here we run into a bit of a tough one with this, with the fraction that we have here. With the fraction, we could turn it into a decimal because in this case it would be like 1 minus 0.75. Okay, but you could also rewrite it as rewrite it so that way the fraction is not. It's a little bit closer to what we would kind of expect to see from a subtraction, where you have your bigger number first, and then you're subtracting the smaller number, which is, it's not always like that, but in this case here, it just worked out that way. I guess sort of as a short thing, I'm going to replace 1, because remember 1 equals any number divided by itself. So 4/4 minus 3/4. Work with the top number, 4 times, or sorry, not 4, 4 minus 3. Bottom number stays the same, does not change. But again, decimals probably would have been just much easier to do than this. All right, now we gotta get rid of this exponent. So I'm gonna go ahead and divide both, not divide, well, it's kind of like division. I don't wanna say it is like division because it's not exactly a division problem. But we're gonna take the square root of both sides because that will undo the exponent. X minus 1 equals positive and negative. Okay, now we have a fraction and we're taking the square root of a fraction. So don't forget what this means also. Oh boy, this fraction one's really gonna, oopsie, go ahead and root both sides. And that means square root of 1 and square root of 4. So we're just taking the square root of the top number and the bottom number. So square root of 1 is 1 and square root of 4 is 2. So this just becomes 1/2. Okay, now break it into 2 separate equations. I'm going to do the negative outcome first. So negative 1/2 and x minus 1 equals the positive 1/2. Plus 1 to both sides. And again, usually when you do this, it's going to be the same. So I'm just going to go ahead and add 1 all the way across to both of my equations here. Okay, and looks like I'm barely going to have enough space to write this out. So this is 1 minus 1/2. 1 minus 1/2. I could write it out like this, where it'd be 4/4 minus 1, or 2/4. But I think in this case, I think you'd be able to kind of know that, you know, if you subtract 1/2 from 1, you're just going to stay with 1/2 because 2 halves make a whole. All right, now with this one here, it looks like we got 1 plus 1.5. So I'm going to turn this one into a mixed number. So 1 and 1/2, which as a decimal, that would be something like 1.5. And we're done with that one. All right, moving on. Same thing, we got to get rid of this decimal. I mean, sorry, not decimal. I'm getting into my, ready to say things, I guess. We got to get rid of this a value, right? That number in the front, we got to get rid of it. So same thing, we're going to have to divide everything by 3. Now, while I'm also at it, I'm going to have to move this over to the other side. So 8/3 is going to have to be on this side. But let's see what we're working with right now. So x squared plus, oh gosh, 10/3 x, leave a space, equals -8/3. So all I did was minus 8/3 from both sides, and that basically just moved it over here, so it's negative now. Now I'm going to have to do the thing with the b value, so take it. So take it, half it, and this is actually, I can understand people having problems with this one because halving a fraction, if you want to half a fraction, what you actually do is you increase the bottom number. All right, let me see if I can explain it like this. Times 1/2. We know that timesing anything by 1/2 is going to take half of it. And we know that when you multiply by a half, it'd be, you know, top number times top number, which 10 times 1 is 10, and 3 times 2 is 6. And I know this is really confusing. I have students of all skill levels that have trouble with fractions because fractions can oftentimes look similar, but actually mean something different. But they can also look the same and mean something different, or they can look different and mean the same thing. Anyway, so take it, half it, square it. So to square this, I got to square the top number. And let's, well, actually, I would also have to reduce it as well because, gosh, 10/6. That is not in simplest form. So to simplify it, in this case here, it is the same. I'm not doing any operation. I'm not dividing it. Okay, I'm just reducing the fraction. 10/6 and 5/3 are the same thing. But now I have to square it. So square the top number, square the bottom number. All right, so that's our new b value. So I have to add 25/9 to both sides. Okay. Now, try our best to factor this. You know, maybe I'll come up with some other way that we can work these out. Because I know some of these are going to be really tough, and I don't want people getting stuck on them. So just wait till the end of the lesson. I'll show you not an easier way, but an alternative way of doing some of these, but just try to stick with me for now. All right, so remember that this number here is going to be the numbers that go into your bubbles, the middle step. And I'm going to use the simplified form just to make things a little bit easier. Oh, gosh. All right, let's go ahead and work on this one now. Adding and subtracting fractions is probably one of the more tougher things to do with fractions because you got to have the bottom number be the same, what we call common denominator. So in order to make this work out, what I'm going to need to do is I am going to triple the numbers here. So that's going to be triple 8, you get 24. Triple 3, you get 9. This one stays the same. It stays 25 over 9 because, well, the bottom number is already going to match if I just make this one bigger. And that's going to make 25 minus 24, which is 1 over 9. Because again, 25 minus 24 is going to be 1. Bottom number stays the same. All right, I'm going to go ahead and take the root of both sides. Square root here, square root there. X plus 5/3 equals, and I'm going to take the root of both of these. So I'm going to take the square root of 1, which is 1, and the square root of 9, which is 3. Don't forget to have your positive and negative result possibility. And now we're going to have to break this into two separate equations. Let's see, 5/3 equals negative 1/3, and x plus 5/3 equals positive 1/3. So again, same thing, one positive, one negative, and I'm really pressed for space here, so I'm gonna go ahead and minus 5/3 from both sides. Now the bottom numbers are already the same, so it's just negative 1 minus 5. So negative 1 minus 5. So that'd be 6. Okay, let's see. Negative 1/3 minus 5/3. So they're both negative, so that would be negative 6/3, which is actually going to be negative 2. So one of the solutions is negative 2. And for this one here, I'm going to have to minus 5/3 like this, and that's going to make another negative number. So bottom numbers are 1 minus 5, which is negative 4. Bottom number stays the same, so that would be 3. And that one was a really tough one. Okay, that I think this one is one of the tougher ones just because there's so much stuff with fractions. All right, so, but I think there's only there are not going to be that many of these. Let me look through the packet and see how many of them there will be with fractions. All right, looks like there's about 2 or 3 of them, just by looking at them. But that's okay. I'm gonna go easy on this. Like I said, I don't want anybody being discouraged and not wanting to do the assignment because, yeah, I know fractions are tough. Okay, I know it. Anyway, we got to keep moving from here. So the solution here and right here. There we go. All right, moving on. Okay, no a value, so that should be good. But we do need to get rid of this 21 here, so I'm going to go ahead and add 21 to both sides. And what we get is 21 minus 5, that would be 16. All right, now we got to take our b value, so take it, half it, square it. So 8 times 8 is 64, and I think this is going to work out. So plus 64 here, plus 64 here. All right, now we do our best to multiply as a perfect square. Now, again, just to keep things normally factored, two numbers that multiply to 64, that'd be 8 and 8, right? And then for our OI, the middle part, they must add to positive 16. So that'd be plus 8, plus 8. So that's 8 plus 8 would be 16. So positive 16, so that works out. And there we go. So I managed to get it to work out. And again, you can always test it. Check it to make sure it's working. And let's see, 16 plus 64 will be 80. And I think we're ready to start trying to solve this. So I'm going to go ahead and take the root of both sides. And luckily for this one, we're not dealing with any fractions. But like I said, the ones with the fractions, I don't think there are that many of them. You're only looking at like 2 or so. So, you know, like I said, I'll go easy on that. Okay, so x plus 8 equals positive and negative. And it looks like we're going to have to simplify this because 80 is not a square number. So let's see, what can we break 80 into? 8 and 10, probably what most people would think of, but neither of those are square numbers. So what I'm going to do is I'm going to take one number and I'm going to put it on the other number, if that makes sense. So I'm going to divide this 10 by 2, but I'm going to multiply this one by 2. So that I'm trying to get the biggest square number out of the whole thing as I can. So 16 and 5 are going to be the combination that I need. Or you can make yourself a table of factors and see which factors are most likeliest to give you the highest value of square number, which in this case is 16. So remember that this is the square root of 16 and square root of 5, which we can take the square root of 16. And we end up with 4 root 5. And this is actually kind of an easier type of problem because we can't really break this into two equations because we would end up with a irrational number. Maybe I'll kind of we'll go over this one on the Desmos just to show you what it looks like when you have an irrational result as your solution. All right, make sure, but we just need to rewrite it. We don't need to actually solve it. We don't need to actually solve this. All right, so I'm going to go to the Desmos and let's see what we can, let's see what we can see. All right, let's get the other one out of here. So that would be x squared, and we're going to type in the one we just got done working on, 16x minus 21 equals negative 5. And in this case, it rounded it off. So we get like negative 16.94. But if we were to punch it into a calculator, we would probably get something similar to what we were looking at earlier, where you have something like this. See, you get long, non-repeating numbers that are basically unpredictable as to where they will, you know, what number will show up next. But anyway, yeah, that's what it's going to look like. This does not mean imaginary solution, and it does not mean no solution. It just means the number is a decimal number. That's kind of weird looking. That's all it means. All right, let's go ahead and do this one here. So I'm going to get rid of this a value. So again, a values, we don't want any of that. So x squared minus 10x equals, and 69 divided by 3 is 23, because 6 divided by 3 is 2, and 9 divided by 3 is, well, 3. Oh, and it looks like we're actually ready to start working with this. I just need to leave some space in here. So I'm going to move this 23 over here. And we're going to have to begin our process of discovering the new C value, this number here. So take it, so grab your B, take it, half it, square it. So it looks like we're going to have to drop a 25 in here. So plus 25, plus 25. And I'm going to do this. Let's see, 5 times 5 is 25. And whenever you have a perfect square trinomial, again, they're gonna be matching. They're gonna have both bubbles with the same value in there. So it's also going to be the sign of the first one. So they're both going to be negative. And again, x minus 5 times x minus 5. But just to keep things a little bit simple, I'm going to go ahead and keep them in this format. So that way I can easily take the square root of both sides. Take the square root because we got to get that x by itself. And that means we got to get rid of all the stuff around it. And it looks like the only problem with this one here is that, again, 48 is not a square number. If it was 49, that would be a different story, but we're just one number off. So let's see, I need two numbers that can multiply to 48. So I'm going to do this one the other way, and we can go 1 times 48 or 2 times 24, 3 times 16. And in fact, I think that is the combination we're going to need is 3 times 16, because 16 is a square number. So I'm going to take the square root of 16. We get 4, but 3 is not a square number. And just a quick show you, we know that the square root of 49 is 7, correct? But let me go ahead and I'm going to clear this off. I'm going to show you what the square root of 4 root 3 is. So 3 square root. Oh, come on. What is going on here? Clear off this whole thing. Square root of 3 times 4. And it should be a number just below 7. So 6.928. So it's just a hair below 7, right? Because again, this is, if this was root 49, then it would be root 7. And in fact, I think with this one here, we are almost done because we have this irrational radical here. So we are going to get a number that is going to, it's going to look just like the one with the calculator, except we're going to have to add and subtract it from 5. So 5 plus and minus 4 root 3. And I should put those little marks in here. See if I can do that a little bit better. And that should be our answer for this one. All right, last page coming up, last slide. Here we are. All right, let's see. No A value, and that should be one step less to do. And I just need to move 43 over to this side, so that would be x squared plus 12x equals, actually I'm going to need to leave a space there, and that would be equals negative 43. But again, I'm trying to make it into a perfect square trinomial, so I got to know what I can put in here so I can easily turn it into a double bubble with the same thing in both of them. All right, so get our b value, take it, half it, square it, which it looks like we're going to have to put in 36. So put in 36, but we got to do it to the same thing to the other side. And now we have our double bubble. And we can factor it again. I'm just going to factor it just because it's just, I think it's easiest one to follow along with. So this would be 6 and 6. But they got to add up to positive 12. So plus 6 here. And it looks like it's going to work out. So I'm going to go ahead and erase this. And square here. And what am I going to get on this side? 36 minus 43. I think we're going to end up with a negative in this case. So it's going to be negative 7. Say 6, 5, 6, 7, 8, 9, 10. Yeah, about 7. Okay, now we're going to have to do the root of both sides. And this one here, it's going to be a weird one because, well, you cannot take the root of a negative number. Okay, we cannot take the root of a negative number. So remember with this lesson, when we covered it earlier, if you have a negative, it'd be like, okay, so negative 7. And that would be root of negative 1 times root of 7. So I'm going to take out the negative 1, and that means it's going to be equivalent to I, imaginary number. Oops, almost forgot the plus and minus. There we go. Now, because this is going to stay a radical or an imaginary complex number, we're not going to have to worry about breaking it into 2 equations because, well, I mean, I guess you could if you really wanted to. You could get the decimal equivalent on both, but we don't really need to. So I'm going to minus 6 from both sides. So minus 6 plus and minus I root 7. And this is probably the best we can do. And put those little brackets in here. And I'm going to kind of reiterate what it looks like to have a imaginary solution on a graph. So let me see if I can save some of this here. So we had 12x plus 43 as the original. And you can see that it's not crossing. It's high up there. It's going the opposite way. Now, if it wasn't a radical imaginary number, and if we were to flip it, you can see that it will switch the other way. Actually, it looks something more like this. Oops, that'd be taking everything. Well, you can reverse the direction and it will cross, all right? But again, it's just not crossing because it's not facing the right way. It's facing the opposite direction that we would need it to be facing. Oops, sorry. There we go, there's the graph. I don't know if I was sharing that earlier. But it's just not crossing the x-axis, so there is no solution. But again, it's not really no solution, it's imaginary solution is what we would call it. All right, next one. Let's go ahead and cover this one here. Divide both sides by, well, actually I gotta get rid of this a value, so everything's gotta go and get divided by 4. So x squared. And 76 divided by 4, I don't know what that is off the top of my head. And let me use my calculator and we get 19. And that's not the x number. The x number is on this side by itself. So it looks like we're gonna have to do a little bit more work to get this to work out. But I'm gonna go ahead and minus 4x from both sides. And I'm also gonna minus 19 from both sides. So basically they just switch places again, minus 19 and minus 4x from both sides. This is just some basic algebra. I'm sorry, I hate to have to skip steps like this sometimes, but I'm just forced to do it sometimes. But again, this is just some basic algebra. Anyway, get the b value, take it, half it, and square it. So it looks like we're going to have to put 4 in there. So add 4 here and add 4 here. Two and x, and they're both going to be the same. All right, remember it's going to be the same as this first one here. So -2 times -2 is +4, and -2 combined with -2 is -4. And it looks like we're going to have -15, which is going to be another complex solution. All right, so I'm going to take the I out, plus and minus, can't forget that. And 15, I'm trying to think, I think 15 cannot be broken into any other numbers, because the only numbers I can think of to multiply to get 15 is 3 and 5, and neither of those are square numbers. So I think we're just going to have to leave all of that in there. But I am going to have to add 2 to both sides, so plus 2 plus 2. And let's see if we can get our solution. Let me go make this thing first, because otherwise it turns out weird like that. Should have been doing that from the beginning. All right, so 2 plus and minus. We took out the negative, right? When you take out the negative, it just becomes I, or imaginary number, root 15. And since we cannot break it into 2 equations and get nice like whole numbers or decimal numbers, right? We're going to get an irrational decimal number, so it doesn't make much sense to keep working on this. So we're just going to go ahead and leave it in this complex imaginary radical form. Okay. Yeah. Anyway, that is it for today. Thank you all for being here, and have a good day.